Hello friends, in this AV we are going to talk about the numericals of chapter 5, that is refraction through a lens. We are going to take up the numericals of exercise 5C, and in this AV we are going to talk about the numericals of remaining part of the exercise 5C, because in the previous AV I have already done half the numericals, or you may say that half the types of numericals. So in this AV we'll take up the remaining numericals. Before we take up those numericals, if this is your first AV, in the previous AV I have spoken about these formulas that we are going to use here. So you can check in the first AV, these are the formulas that we are going to use, and they will help us solve the numerical quite easily. So let's take up question number 10. It says a concave lens forms an erect image of 1/3 size of the object. That means the image reduces in size, which is placed at a distance 30 centimeter in front of the lens. That means u is equal to minus 30 centimeter. We have to find the position and the focal length of the lens. So here I have written the given things, that is distance of the object u is equal to minus 30 centimeter and magnification is 1/3. So we know that the magnification is equal to v upon u, that is image distance upon object distance. So we put the values. Magnification is 1/3 is equal to v, we have to find out, and object distance is minus 30. So after calculation it comes out to be minus 10 centimeter. So image is formed at 10 centimeter, and the sign minus shows us or tells us that the image will be formed in front of the lens. The second part, we have to find the focal length. So here we have used the lens formula. We know, or the lens formula is 1/f is equal to 1/v minus 1/u. So we know the value of v, we have already calculated above, that is minus 10, and the value of u is given to us in the question, that is minus 30. So this minus goes up, we write it in numerator, and minus into minus becomes plus. So we get minus 1/10 plus 1/30. So after simplification we get it as minus 2 upon 30, that is minus 1 upon 15. So 1/f is 1 upon 15, so f is equal to minus 15 centimeter. Let's take up question number 11. It says the power of a lens is plus 2 diopter. We have to find its focal length and state the kind of the lens. So kind of the lens means whether concave or convex. So here we have to know that if power is positive, like in this question the power is positive, so the lens is going to be convex, and if the power was negative then the lens would be concave. So we have written the things that are given to us, that is power is equal to plus 2 diopter. So we know the formula, power in diopter is equal to 1 by focal length, which is taken in meters. So if we interchange, focal length will be 1 upon power, so that is 1/2. If you divide, you get 0.5 meter. So you can leave it here, or you may extend it and convert it to centimeter. So here 0.5 meter or focal length is 50 centimeter. Please note that when power is positive the lens is convex, and when the power is negative the lens is concave. Let's take question number 12. It says express the power with sign of a concave lens of focal length 20 centimeter. So the moment they say concave lens, we know that the sign is going to be negative. So let's do it. So here we have given that the focal length is 20 centimeter. The formula says that focal length has to be put in terms of meters. So we convert it by dividing it by 100. So we get focal length is equal to 0.2 meters. Now we know that power is equal to 1 by focal length or 1 upon focal length. So we simply put the value. So 1 upon 0.2. So when you divide it, the power comes out to be 5 diopter, and therefore the power or the value of power will be minus 5 diopter. As the lens is concave, so the power will be negative. Let's take question number 15. It says the magnification by a lens is minus 3. Name the lens and state how U and V are related. So here you can check, we have written the given things. Given that the magnification is minus 3. Now for convex lens, magnification is positive or negative, but for concave lens, magnification is always positive. So here it's negative, so the lens is convex. Now we know that the magnification is equal to V upon U. Magnification is minus 3 is equal to V upon U. So you just cross multiply. So V will be equal to minus 3U, and lens is convex because the power is the magnification is negative. Now let's take up question number 17. It says a concave lens is of focal length 30 centimeter, is of focal length 30 centimeter. Find the position and magnification of image for an object which is placed in front of it at a distance 30 centimeter. State whether the image is real or virtual. So here we will write the given things. So you may see focal length is minus 30 centimeter. U, that is the object distance, is minus 30 centimeter. So we know the that 1 by focal length is equal to 1 by V minus 1 by U, that is lens formula or lens maker formula. We have to calculate this value 1 by V. So we keep it on one side and rest everything we take to the other side. So 1 by V is equal to 1 by F plus 1 by U. Minus 1 by U going that side becomes plus 1 by U. So 1 by V is equal to 1 by minus 30. So minus I have written in the numerator, plus 1 by minus 30. Again minus into plus will make this plus as minus. So it becomes minus 1 by 30 minus 1 by 30. LCM would be 30 minus 1 becomes minus 2. So minus 2 upon 30 is equal to minus 1 upon 15. So this is 1 by V. So V will be minus 15 centimeter. This minus indicates that the image is formed in front of the lens. And the second part, we have to calculate the magnification. So we know the formula for magnification is V upon U, that is image distance upon object distance. So that is equal to minus 15 upon minus 30. Again it will be 1 by 2, so plus 0.5, and since this is positive, magnification is positive, so the image is virtual and erect. Let's take up the last question. It says find the position and magnification of the image of an object placed at a distance of 8 cm in front of a convex lens of focal length 10 cm. Is the image erect or inverted? Erect means virtual or erect, virtual and erect, and real and inverted. So if we know whether it's a real image or virtual image, then we know whether it's erect or inverted. So the given things are U is equal to minus 8 centimeter, focal length is 10 centimeter. This sign conventions you may check in the first part of the video. If you know or if you have understood the sign convention, you don't need to remember. In case you don't, then please remember what all signs we take for concave and convex lenses. So we know that the lens formula is 1 by f is equal to 1 by v minus 1 upon u. We have to calculate 1 upon v. We have to calculate the value of v. So we write 1 by v is equal to 1 by f plus 1 by u. So we substitute the value. 1 by v is equal to 1 upon 10 minus 1 upon 8. We do the calculation. These are basic maths. So we get 1 by v is equal to minus 1 upon 40. So we just take the reciprocal. So the value of v is equal to minus 40 centimeter, and since we get minus, that means it will be formed in front of the lens. Now magnification m is equal to v upon u. This is the formula. So we have calculated the value of v minus 40 centimeter. So minus 40, and u is given as minus 8 centimeters. So we write minus 8. So minus 40 upon minus 8, minus minus cancel, and when you divide, you get it as plus 5.0. So magnification is positive. That means the image is virtual, and with virtual we have erect. With real we have inverted. With virtual we have erect. So here the image is going to be erect. That's all we have in this AV for you. Thank you so much. Blessed learning.